Hello guys, welcome to another Kaczynski video. Today I'm going to explain the code used in the square buildup transition as seen in part 1. So if you've not seen it yet, I suggest that you do so to understand what I'm talking about here. So I do have to note that some of the concepts that I'm going to explain require basic programming knowledge, so this video is basically for intermediate to professional programmers. Anyways, let's get into the video. So I have pulled up the code for the hard transition, so basically the first lines of the code, of the function basically. It's pretty straightforward. I'm just defining variables needed for transition, so to understand them better, it's better to watch the first video. Anyways, we have our first nested loop, so this whole statement right here, which basically indicates that we have the first stage of the transition of going to a black screen. So we want to achieve a pattern of filling up the screen that is frankly similar to imposing an inverted half pyramid, and then when either the first column or row has filled up the screen, then it will fill up the rest of the screen in a diagonal pattern as seen here. We will achieve this by cloning and tweeting a certain amount of frames for each iteration of the loop. So basically, the first loop statement, which is this statement right here, so for I equals 1 repeat amount do, it basically tells us how many times we want to repeat the process of cloning and tweeting frames. And basically, in my example, since we're doing for I equals 1 up to repeat amount, and we have defined that repeat amount is 16, 7 plus 10 minus 1, 16. That means we're going to repeat this process 16 times. And the second loop statement, so for k equals 1, I do, so this whole statement here is like another loop here, tells us how many UI frames we want to put onto the screen in each iteration in the first loop. The value of I will increment after the iteration of both loops. So let's say this loop has been iterated once and this loop has now been iterated over, then the value of I will increase. Hence, the number of frames that will be put onto the screen at once will change depending on how much we filled up the screen. It is worth mentioning that both I and k in this code are variables that we continuously assign dynamically as we iterate both loops, so both will have a value. The first if statement, as seen here, the one I'm highlighting right now, basically prevents the script from crashing because eventually the variable k may or may not reach a value that will be greater than the number of rows that we have. So k will increment continuously based on the value of I, and it may reach bigger than the number of rows that you have. For example, in my case, I have 7 rows and 10 columns. Thus, I'm repeating this nested loop 16 times. The variable I will reach to 8, 9, 10 up to 16, and we don't have 16 rows, for example. The value of I will influence the value of k as k continues to increment as part of the loop. Whether the value of k will be 8, 9, 10, or so on, it's still greater than the number of rows that we have. And this line of code relies on the value of k. So if k were to be 8, for example, the code will look for row 8, which does not exist, thus breaking the code. So I will break out this loop using this conditional right here, just to prevent the script from crashing. And basically, the second if statement, this right here, just reduces the amount of assets. So basically, when we keep inserting frames into rows, because of the value of k, which will exceed 10, and just to note that 10 is basically the number of columns that we have, it will keep inserting frames. But we do not see it because the frame is inserted outside of the screen from the player's point of view. Thus, we want to minimize the amount of assets by just continuing on to the next row if a row already has 11 items, which consists of 10 frames and a UI grid layout. I think this code is best represented visually. So let's say this is an empty screen, this entire grid. And I've added outlines just to make it clearer and for you guys to distinguish the frames. And I've also labeled the rows from 1 to 7. And I've also pulled up our code just for reference. This does not include tweeting the frame. I just want to show how the program knows the exact frames that should be visible within an iteration. And I want to show you a simulation of how this nested loop would work. So let's start off with our first iteration. So we initialize the variable to be 1 at first. Then we can repeat 1 time as said in this statement. So k will at first be initialized to 1. There is a row 1, and we do not have any frames inside row 1, therefore passing both conditions, and therefore we can move on and clone our frame and insert it into row 1 like this. In the next iteration, I will be incremented to 2, so the value of I is 2, and therefore we can repeat the process 2 times. So k will at first be initialized to 1, and there is a row 1 passing this condition, and there is only 2 items technically. That includes the first frame and a UI grid layout in the first row. Therefore, it's less than 11, which is the amount of columns, 10 plus 1, the UI grid layout. So that's 11 items, and therefore we also pass this condition, and thus we can clone and insert a frame into row 1 like this. So you may notice that we are adding frames from the left side instead of the right, and that's because in the horizontal alignment property in the UI grid layout of each row, you can see that it is set to the left by default instead of the right. So therefore, any frames that we insert into the row will start from the left rather from the right. So now we move on to our next iteration of k. So k will equal to 2, and we pass this statement because there is a row 2, and we also pass this statement because we essentially only have one item inside of row 2. So now we can clone and insert a frame into row 2. The whole loop is done. We can increment I yet again to 3, and k will increment 3 times. We start off with k will be initialized to 1, and there is a row 1, and there's like 3 items inside of row 1. Thus we pass this condition, and we can clone and insert a frame into row 1. Yet again, k will increment to 2, passing these conditions, and we can insert another frame into row 2. K will increment to 3. Passing these conditions, there is a row 3, and there's only one item inside of row 3. Therefore, we can clone and insert a frame into row 3. So I think you can see the pattern that is happening. And as I mentioned before, it clones and inserts frames into the designated rows all at once. However, I'm just showing you the process step by step just to make it more comprehensive. Moving on from line 61 to line 65, we are adjusting the properties of the frame to make it visible in a certain row, ready to be tweened, and also identifiable, which will be useful for our next nested loop. Line 67 to line 69 means we're going to find the child frame of the parent frame that was cloned into the row and do the tweening, simply because Roblox does not allow you to tween the parent frame, but rather the child frame. So you can see in the frame there is a parent and a child frame, and we will tween the child frame. Next up, we move on to our next nested loop, which basically indicates the transition from going to a black screen to a blank screen. So now this condition right here basically functions the same way as the condition found in our first loop. And now this nested loop will allow us to search through each row of the frames, and we want to know in each row what frame do we want to delete. And we can achieve this by using the formula I minus k plus 1. And I and k are variables that are found within our nested loop. So I can demonstrate this live. So let's say this is the entire black screen, and I've added white outlines just for you guys to distinguish the frames. I've labeled the rows, and I've also labeled the columns. So think of it this way. This is frame 1 of row 1, frame 2 of row 1, and so on. So now let's simulate the process of how this nested loop would work. So I will be initialized to 1 at first, then k will also be initialized to 1. This will repeat one time. So if k equals to 1, well, there is a row 1, so we pass this conditional, and now we look in row 1, we look for the frame I minus k plus 1. So if I equals 1 and k is 1, so 1 minus 1 plus 1, we're looking for frame 1 in row 1. So this frame right here, and that's when we know what to shrink. Now we increment the value of I to be 2 now. So if I is 2, then k will increment 2 times. But first, k will initialize to be 1 at first. So there is a row 1, so that passes this conditional. And in row 1, we're looking for I minus k plus 1. Remember, if I is 2, k is 1, 2 minus 1 plus 1, that is going to be 2. So we're going to be looking for frame 2. And likewise, if we increment the value of k to be 2, well, there is a row 2, and if I is 2 and k is 2, so 2 minus 2 plus 1, we're looking for frame 1 in row 2. And this pattern will repeat so on and so forth, but that's basically how it works. Moving back to the code, we can see this conditional right here that basically prevents the script from breaking. This is because theoretically, if the number produced by this formula, I minus k plus 1, will eventually result in a number greater than 10, which is the amount of columns that we have, or less than 1, then the game cannot find the frame in the certain row that we're looking for, row k, and the code breaks. These situations are bound to happen as I or k can reach up to 16. So this conditional is just a preventative measure. And straightforward, these two lines essentially help tween the child frame to shrink it really small as if it's being deleted. The reason why we cannot delete the frame straight away after shrinking the size is because it will look something like this, for example. Bruh. Therefore, we have to wait for the entire nested loop to finish if we want to delete all frames at once. And this is basically what this for loop does. So basically, this for loop is telling us that we're going to go through each and every row of frames to clear out the frames. Pretty straightforward. Anyways, that's the end of the video. I hope you now have a solid understanding of how the code actually works. And I hope I had a decent explanation of how it works or functions. Anyways, I'll see you guys in the next video.